Okay, so what we're going to look at today is the beginning of Chapter 3. The first lesson's called a review and a preview. So it's looking at some topics that we are going to be using a lot in this unit, namely rounding and substitution. Even though you've learned or you've been rounding for several years now, there's still some confusion in how to properly round numbers. So when we do a calculation, the answer sometimes or a lot of times is a non-terminating decimal or it contains a large number of digits. In such cases, we are asked to round off the answer to a particular degree of accuracy. In science class, you deal with significant digits. In math class, you're told what to round to. So in math class, you'll be told to round to the nearest tenth or hundredth, or the nearest $1,000, or the nearest whole number. So you will always be given what to round to. If you're not given what to round to, then as long as you round correctly, you won't get it marked wrong. I will not look at whether or not you use significant digits properly, because it's not part of the curriculum outcomes in this class. So the best thing, actually I can't remember where I saw it, was a little app for rounding that actually looked at it and made it into a hill. Or the other way to look at it is if this was on a ruler, where would you be closer to? So if I have 65,182 and 491 thousandths, is this 4/10? Or sorry, this 49, like this 4/10 or this 4/9, is this number closer to 5, or sorry, we're going to the whole number, sorry. So to 0.4, is this 65,182.491? If I put it on a number line, is it closer to 182 or 183? That's the question to ask yourself. Don't look at double rounding. Don't look at, well, the 9 would bump this up to a 5, and then the 5 bumps that up to a 3. No. If you're asked to round to the nearest whole number, you look at the tenths. Is this number closer to 162 or 163? That's what we look at. So if I was rounding to the nearest 10, if I'm rounding to the nearest 10, I look at the ones. So this number here, is it closer to 180 or 190? That's what it means to round to the nearest 10. If I'm rounding to the nearest 100, I look at the tens place. So the question to ask, 132, is that closer to 100 or 200? So it's always which one is it closest to. And we only round once. So we don't, like I said, we don't double round. If I'm rounding to one decimal place or to the nearest tenth, I look at the hundredths digit. Is this closer to 4/10 or 5/10? And it's closer to 4/10. If I'm looking at the hundredths, then I look at the thousandths place. So this is 491. The question to ask, is this closer to 49 or to 50? So because this is less than 5, it tells me to leave the 9 where it is. But I always like thinking or visualizing it, putting it on a number line, or if you put it on a hill. I have to try to see. Just wait. At the top of the next page, what I want you to do is take these two numbers. Actually, we'll do the first row together, and then you'll do the second row on your own. If I take 538 and 5,968 10,000ths, that's how I would read that number, and I round it to the nearest 1, or in other words, the nearest whole number. What would that whole number be?
539.
Okay. Now I want someone else to tell me what that number would be rounded to the nearest 10.
540.
540. Someone else, tell me what would that number be rounded to the nearest 100.
500.
Thank you, Colin. Someone else, tell me what it would be rounded to the nearest 10th. Thank you, Kate. To the nearest hundredth. I need someone else to tell me what it would be rounded to the nearest hundredth. Connor, what did you get
Which one?
for the nearest hundredth?
538.60.
Is that 0 important?
Yeah.
Yes, because it is rounded to the nearest hundredth. And if it's to the first decimal place, what does that look like? It's the same as the 10th. And second decimal place would be the same as the hundredth. Okay, so do the second row, please. When you are done, and you want to come fill one of these in the chart in, come up and fill it in, please. Right, better than that.
I would never ask. Never will.
You never will say that?
My rating
I
is
read like
reduced to
Wallinga.
Sterlinga's.
So the tenths become the same as to 1 decimal place,
Colin, did you do that?
and the hundredth
Yeah.
is 2 decimal places. For those of us watching, this is 9, 6, and
Yeah.
4.
Colin, I don't think you're allowed to. I'm sorry.
Yeah.
Okay.
Yeah, I'm not allowed to write. Colin, you're not allowed to put down numbers.
Yeah, on boards.
Okay. The next part looks at using a calculator to round. I'm not going to go through that very much because I don't think it's necessary. You should know how to round without using your calculator. However, using your calculator to round, where's my calculator? There's my calculator out. To use your calculator to round, where you're going to go to is in the mode. Now, the one time that it's actually useful to have your calculator set on a certain rounding amount is when you're dealing with money, because money is always rounded to 2 decimal places. So in this row here where it says float, I can scroll down and I can set this to 2 decimal places. And then if I was dealing with money calculations, once I've done that, I can quit and go onto my screen. And let's say I wanted to take a percentage. I was calculating interest rate. So I want to take 1.5%, so it'd be 0.01, $475. It automatically rounds it to $7.13 for me without me having to go through and round it myself. The problem is, if you forget that you've set your calculator to 2 decimal places, it will do that for everything and it'll start to play with your calculations. That's why I don't like using the calculator to round, because you've been rounding since elementary. You know how to round.
Should have been sweaty.
Okay? So if you want to read through the next couple of pages on using the graphing calculator for rounding, you can. But like I said, I'm not going to go through it. I don't think rounding in that regard is beneficial. You need to know how to round without using the calculator. So what I want you guys to do is, if you look at class example number 2, it says use a graphing calculator to round off where indicated. Let's just round them. If I take 10.6217 and I round it to 3 decimal places, what will I get? 10.622.
Well, 7 is higher than 5.
So the 7 is going to make the 1 become a 2?
There's another 2 there.
622.
9 there.
Oh, yeah,
Look at your
sorry.
page.
Yeah, sorry.
Okay.
I'm like Connor right now.
If I take 15.382 or 382 thousandths and I round it to the nearest hundredth, what would I get? 15 point what? Thank you. If I take my calculator without it being in that rounding mode, and I go 4,863 divided by 219, I get 22.20547,945. To the nearest tenth would be 22.2. How would I read that properly as a number?
22 and 210.
Thank you. And the last one, if I take 1 and 95 hundredths and multiply it by 4 and 68 hundredths, to 2 decimal places, that would be what?
9 and 1300.
Good job, 9 and 13 hundredths. If you round in scientific notation, so if you're given scientific notation and you're asked to round to the nearest tenth or to the nearest hundredth, what they're talking about rounding is this base number here. So if I take the number 150 million, tell you to write it in scientific notation rounded to the nearest tenth, it means 1 decimal place in my base. So if we look at the 2 numbers in class example number 3, 75,300,000. In scientific notation would be 7.53 times 10 to the power of what? 7. So if I change it to the nearest 10, my 7.53 would become
7.5.
7.5. So now if I take this small number and I write it in scientific notation, it becomes 3.892 times 10 to the power of what? -5. So now if I change this to be to the nearest 10th, what happens to my 3.892? But my 10 to the power of -5 will stay the same. It's the base that changes, not the power.
No power here.
So try to do class example number 4 on your own. And I'll give you a couple minutes to do those questions. So what we will look at right now is substitution in algebraic expressions. We've done this over the last couple of years. We're just going to talk about some of the techniques and a little bit of the technical aspect to substitution. So the big thing when you're doing substitution is brackets help. Brackets help you isolate that substituted in value and make it less likely that you're going to make mistakes. So if we look at class example number 5, which is on page 116, it says find the value of each of the following if x is equal to 2 and y is equal to -3. So if I look at the first expression, y squared minus 7x minus 3, where I see y squared, I substitute in -3, and where I see x, I substitute in 2. So what is -3 squared? +9. And then look at this, treat this as a -7 times 2. So I have 9 minus 14 minus 3 would equal -8. Okay, I'll give you a moment. I want you to try to do B on your own. So again, where I see an X, I'm going to substitute that in with a 2. And where I see a Y, I substitute in a -3. Now, things to watch out for when we're doing this question. in the 9x squared, it is only the 2 that is being squared. So this becomes 9 times 4. It's not 9 times 2 and then square the answer. The 2 negatives minus a negative 3, I can simplify into a positive 3. And then the cubed root of negative 3 becomes negative 27. So 36 plus 3. And then I can simplify this plus a negative into being minus. So I get 39 minus 27, which is 12?
Yep.
Okay. The next part of the book talks about substitution with a graphing calculator. I'm skipping over that because it's kind of like rounding with your calculator. I don't want you to become dependent on the calculator for something that you should be able to do. Substitution into a formula is something you should be able to actually determine. It's not something that you should be using your calculator for. And there's actually probably a little bit easier of a system rather than what they're giving to you on the calculator. We generally in high school don't do a lot of questions where we're doing a lot of substitution that we would need to use our graphing calculator. It becomes more time consuming. It would take you more time to actually set this question up than it would to actually solve it mathematically on paper. So instead, I'm going to skip over to class example number 7, which is substitution in formulas. This should come as a bit of review with what you've done in physics, because I know in physics this year you worked with formulas, and it's also a precursor for physics 20. Physics 20, there's the use of a lot of formulas and the manipulation of those formulas. So giving you a formula and saying, well, if I have 60 equals v times t, how do I get t by itself? Or how do I solve for the unknown variable? So in each of the following, substitute the given value, and then calculate the value for the variable indicated to the nearest tenth. So if 60 equals v times t, and v is equal to 12, I substitute 12 in. I don't necessarily need to use the brackets because I've got a variable still in there and the brackets might become a little bit more cluttered. But if you want to put the brackets in, it'll still be fine. How would I get t by itself? How would I get rid of that 12?
Divide by 12.
Divide by 12. And I divide because the 12 and the t are being multiplied together. So I undo that multiplication through division. 12 divided by 12 is?
1.
So I get 1t or just t. And 60 divided by 12? 5. Okay, so again, try to see if you can do B and C on your own. So if I look at B, I have that S is equal to 100, and R is what I'm trying to calculate. So to get R by itself, I have to get rid of the 4 and the pi. How do I get rid of the 4 and the pi?
Divide.
I can divide. 4 divided by 4 is
1.
1, and pi divided by pi is
1.
1. So that would leave me with R by itself. The other thing to look at is these are all being multiplied together, so to undo the multiplication, I divide. When I put this in my calculator, I need to be very careful. I can do this in 2 steps. I can go 100 divided by 4, answer, which is 25, and then 25 divided by pi, which is going to give me 6 point something.
7.
7 point what?
9, 5, 7, 7, 4, 7, 1, 5, 5.
So to the nearest tenth would be
8.0.
okay. If I was to try to do this all in one step on my calculator, I would use brackets. So I'd go 100 divided by open bracket 4 pi close bracket. And that will give me the 8.0 rounded answer. For question C, V is equal to 95. And I get 4/3 pi r cubed. So I want to get this r by itself, or this r cubed by itself. So let's start with my 4/3. How do I get rid of the 4/3? And dividing by 4/3 is the same as doing what? How do I divide fractions?
Multiply with the reciprocal.
Multiply by the reciprocal. So dividing by 4/3 is the same as multiplying by, so that's my first step. I'm going to multiply both sides by 3/4. And then I have to get rid of this pi. So how do I get rid of the pi? Divide by pi. So what I end up having is I have this r cubed. I have 95 times 3 over 4 times pi. And how would I go from r cubed to r?
Cube root it.
Cubed root it. So r would equal the cubed root of this entire expression. So when I go to put this in my calculator, the cubed root button on my calculator I can find by pressing math and choosing number 4. And then I have to tell the calculator what order to put this in. Now, depending on your calculator, if your calculator opens up a set of brackets right away, now you're going to need to open up a second set of brackets. And you need to tell the calculator go 95 times 3, and then close the bracket. Then you're going to divide. And then you're going to tell the calculator to open up another set of brackets and go 4 divided by pi. Or sorry, 4 times pi. And those two brackets tell the calculator to do this calculation and this calculation separately, and then divide the two answers, and then finally cube root the whole thing. So again, 2.8. I can do this in more than one step though. I could go 95 times 3 equals, and then I could divide that by 4, divide that by pi, and then I could cube root that answer as well. So if I cube root that answer, math, selection number 4, then I can tell the calculator take that answer. So I go second, and the negative button, and ANS, which stands for answer, appears on the screen. And when I press enter, there's my 2.83. So you can do it all in one step, or you can take a couple of steps to get down to it. And sometimes it's better to start small and do those in between steps than to try to skip and do it all at once. So R equals 2.8. Class example number 8 just asks us to manipulate formulas again. But this time, instead of substituting for the given value first, they want you to isolate the variable first. So if I have S equals pi times R divided by 4, and I want to isolate for R. I want to get R by itself. So think about how I built this side of the equation. I took R, I multiplied it by pi, and I divided by 4. So if I undo all of that, what would I do to work backwards? Multiply by 4 first, and then divide by pi. So R would equal 4S divided by pi. So if S equals 75, I get 4 times 75 divided by pi, and I'll get you guys to tell me what the answer would be. To the nearest 10th. What'd you get, Jonathan?
95.5.
Jonathan? Good. Okay, so now if I look at B. If A equals pi r squared, solve for r, and then calculate the value of r when A is equal to 72. So if I want to get this r by itself, how did I build it? Well, I squared the r, and then I multiplied it by pi.
We want to divide by pi. We find
So-
the square root.
Divide by pi first, and then how do I get rid of the square?
Find the square root.
I square root. So I'm going to take the square root of A divided by pi. So when A equals 72, I will get 72 divided by pi, and I'll take the square root of that. So try doing that on your calculators and tell me what you get. Does the calculator say anything? Okay. So to the nearest 10th, Isa, what did you get? 4.8. Agree or disagree?
Agreed.
Agree? Okay. What separates the formula in C from the rest of the formulas we've looked at? It's got a fraction in it. Okay? So how do I get rid of that 1/3 fraction?
Divide by the reciprocal.
Okay, so if I divide by 1/3, that's the same as multiplying by 3. So I get rid of this fraction by multiplying both sides by 3. And now I have 3 times v equals pi r squared h. How do I get the h by itself? Or in other words, how do I get rid of the pi and the r squared? Through division. Pi divided by pi will equal 1. R squared divided by r squared will equal 1. So if v equals 20 and r equals 9, to the nearest 10th, what does h equal? And be careful because you have two you have things that you have to do on the top and on the bottom separately.